So today we're talking about two different things. So the first thing has to do with, if I grabbed a box there down off the shelf, there's an amount of stuff that can fit in that box that could be measured. Does anybody know what the name is of a measurement of how much like stuff, space can fit in a box?
Volume?
That is correct. So that is what we're talking about today, is volume. It's kind of like if you have a flat shape, we did the area. Do you remember the very first day when we did area? I drew you a rectangle, and then I did something to my drawing so that we could count something. Does anybody remember?
You made a dotted line that was a right angle to another line.
Sometimes we did that, yeah, but this is way back to like September. If this were like 2 this way and 4 that way, what would the area be for that? 8. How could I draw so that you could see 8 of something? Any memories of area, how I could give that meaning?
Put it on the inside?
Yeah, it has to do with the inside. There's a place in my room right now that we have an example of this, actually, that I could find the area of something in the room by counting them.
Draw squares inside?
Yeah, draw squares inside. So if this is 2, I could make 2 levels. If this is 4, I could do like 4 stacks, and then we're counting up the squares. The area of that is like 8 squares. Right now in my room, where do we have the ability to count squares?
The lockers. Right there. The lockers. Right there.
I'm standing on it. Yeah, my tiles. If you're counting like floor tiles, or even ceiling tiles maybe could work. You're counting something like that. You're counting area. If you're counting how much like space inside a flat thing. Volume, we're not going to count squares. I did a little bit of the similar like drawing on this. If this is 4 across, I made 4 stacks. If this is 3 high, I made like 3 floors. Like if this is a hotel, there's like first floor, second floor, third floor. It's 2 deep, so I have like a front in front of a back. And I drew this in such a way that we could just count. The very beginning homeworks will start to ask you like building up kind of questions. Like how many blocks are just on the top? If we just looked at the top, how many boxes are up there?
8.
8. How many levels just like the top exist? 3. So grand total of box count? 24. They could also ask a question like, how many boxes are on this right edge? If we count up the boxes on the right edge, there's
6.
6. How many stacks just like that are there?
2.
3, 4.
4. 1, 2, 3, 4. So how many boxes did that make? 8. They could also ask maybe something like, how many boxes do you see on the front?
12.
12. How many layers like that front are there? 2. There's a front, there's also a back. So 12 and 12 makes 24. All of those roads led us to what final answer?
24.
24. So I think the first question or two they'll ask in the homework, it kind of takes you like step by step, asking you about the different locations. But in the end, the volume is 24, and you don't need a human being to come along and draw all those lines and actually count those boxes. What did we do to those numbers? We multiply. So you're going to want to multiply a length times a width times a height. There should be 3 dimensions on these boxes. You multiply those 3 numbers, and that's going to tell you what's in there. What is the name of these shapes? If I could draw a little better, let's act like I can draw. What shape are those boxes?
Cube.
They are cubes. So instead of counting squares for area, like the thing that I erased, we're counting cubes for this. So if I shoot you this one, I don't have the patience to draw 7 levels. I don't have the patience to draw like 3, front, middle, back. I don't have the patience to draw a 4-story building. I'd end up making a lot of drawing there, and I don't need to. We just need to multiply the length, width, and height, and that's going to tell us how many of these cubes there would be in this shape, and there's a lot. Somebody do that up.
84.
84 is correct. Does it matter what order you multiply? No. So I personally, I'll usually do the littler ones. 4 times 3 is 12. Because 12, I still know my times tables. 12 times 7, I think that's maybe the quickest way to get 84. But you could go 7 times 4 is 28, and then do that times 3. You could go 3 times 7 is 21 times 4. Doesn't matter the order, you just need to multiply the 3 numbers. Let me go to this one. So if we do this one, what would we-
150.
it is 150. He's been the dominant voice so far, so I only know that one person can do that. Did that make sense to you?
Yeah.
Are you with that? Yeah? You understand? You good? Everybody's good? If I go to do this one, what's a little different about this? We're again just assuming I can draw. That's true, I only put a 4. I thought, what's different here?
It's all equal.
It's all equal. What shape's that called again, where they're all the same?
A cube.
It's a cube. So this is a 4, means that
Four.
that's a 4, means
That's
that's a 4. Okay, what we're gonna have to do for all of these boxes is have 3 numbers. If it's a cube, just use the same number 3 times. So what multiplication has to happen off of this?
4 to the power of 3.
4 to the power of 3, which means also 4 times 4 times 4. So somebody other than our voice so far, do that out for me. It is 64. Question about the idea of volume. Then I have one thing I'll have to add on. Every time we've had anything with shapes, the book and I have added this on at the end. What could be on these shapes that's going to cause us a little bit more information to flow?
like inches.
Inches or something. So if this is a box that has inches, that's not going to hold a lot of stuff. Okay, if this is a box that has miles, that is really going to hold a lot of stuff. That makes a difference. Okay, it makes a big difference if we're measuring inches or miles. So if I do inches, you're going to absolutely have to do something about the inches. It's just a question about how to write it. So what, other than just seeing inches before, what other inches have we seen sometimes? Square inches. So when we did square inches, we either put on a little
S.
little 2 there, or we'd squeeze in here a little
S cubed.
S cubed for square. Okay, for what math thing did we do that?
Area.
Area. So the area problem I erased, we were counting squares. So we put little 2's, we put little S cubes. That is not what we're doing today exactly. Does anybody have a theory of what we're doing?
It will be 24, and then the inches, and then there will be a little 3, because 3
There
means
is-
cube.
That's correct. We're no longer counting squares, we're counting cubes. So we learned on exponent day, cube, we can put 3's on things. The third power was cubed, second power was squared. Another way you could make sense of this is, you're multiplying how many numbers?
3.
3. If you multiply 3 numbers, you're going to need a third power. Inches times inches times inches, the inches, there's 3 of them. When we're doing areas, you're only multiplying 2 at a time. Another way you could do this is with just the letters CU for cube. It doesn't matter which way you pick, you just have to pick something. So if I walk in and I just give you numbers, you just give me back the number. You don't say 84 and then put a 3. That's not what you mean at all. What would this crazy thing mean to do?
Times it by 3.
84
Times 84.
times 84 times 84. You don't mean that. You mean 84. So if I just do numbers, you just come back at me with numbers. But if I come at you with miles, you have to come back with some sort of a way of doing the miles. You could either put miles with the little 3 or sneak in
CU.
CU. Either way you do it is fine. You just pick whatever thing you like better. That's main event 1 is volume. Question about volume? Second thing we're doing is starting to talk about this shape, which if I could draw is called a circle. So circles have parts. All we're going to do today is learn some vocabulary words or remind you of some vocabulary words that have to do with circles. Does anybody know anything about a word that has anything to do with parts of a circle? because the circle has some parts to it.
Like boundary?
It does have a boundary, but that won't be one of our words. There's an R word that is circles, a D word that's a circle word. There's 3 different C words that are circle words, but I don't suspect you're gonna know one of them, and the book doesn't even do it, so it doesn't really matter. But there's
Center?
center is a word. I like that. That's a hit. Where is the center?
At the center.
That's center, right there. So that is the center of the circle. Probably in elementary school sometime, if your teachers trusted you not to harm your fellow students, you may have drawn a circle using a certain tool. Can anybody either name or describe a tool that exists that you could use to draw a circle? But it's a little scary to give them to young children because they can hurt other people with them.
A scissors.
Not scissors.
I don't know what it's called, but isn't it the thing that has like the pencil in the middle and you go around with it?
Yeah, one side's a pencil, what's on the other side?
A marker.
No, it's
A knife.
Thick little thing.
Yeah, like a,
They used it, didn't they?
doesn't it start with a P?
I don't know what that piece is even called, but it's like, why don't you want?
Tractor.
What, you're getting, that's a different tool.
It's
Protractor is a different tool. Why don't you want to give one of these circle drawing tools to young-ish people?
It's sharp.
It's sharp, okay? The pencils are always a little bit sharp, but what's the other end usually made out of?
Like metal.
Like metal, and it's like real sharp, because what you're supposed to do is jab that into your paper, not your like fellow student.
I think it's
I would probably
There's like a thing that like tightens up, like a screw thing that tightens
Yeah.
up, so it
I
like
used
holds the
roll
pencil in place. You jab the metal end into your paper, and then you basically like trace a thing out like this.
My grandpa gave me one.
If you have a cheaper one, what always happens as you write is the pressure from your hand causes it to slip, and your circle comes out like an egg. Just sort of does. But if you have a good one, it tightens up. You jab it in there, you trace it out. It's a C word that I don't mean to put on the board. It's also a C word that has to do with the Boy Scout thing that's completely different,
Call.
that you use to find your way through the woods with north, south, east, and
Compass.
west. A compass. So that thing with the pencil and the like metal jabby end is called a compass. But all that I say to say that the center is where you jab in the metal. So wherever you jabbed in the metal, that's the center of the circle. Sometimes when they manufacture stuff, this doesn't have it. Sometimes there's even just like a little dot. You can see something was like, when they made this cylinder, it was probably held by like 2 things like this. Sometimes it leaves a mark. Like you'll see a mark where the center would have been when the equipment like made things. But yes, all that to say, center, that is an item. What makes a circle special is every point on this circle is the same distance from the center. Like if I draw a center and I go 4 inches this way, 4 inches that way, 4 inches this way, 4 inches this way, and 4 inches all kind of like diagonal directions, every single dot I'm doing is 4 inches away from that center. If I had all of eternity to do this, sooner or later, I'd get it all and I'd have like a solid thing going around there. But that's what makes a circle be a circle. Every single position on the circle, it's the same distance from the center as every other point is from that center. So there's a word. Any other words that you maybe remember?
Round.
No?
Oh, I was trying to say rectangle.
No. If we measure this distance from the center to the circle, that would be an important distance to measure. Like here, it was like I had said, for example, maybe that's like 4 inches. That's one of our R words. That's called the R something or other of the circle.
I thought that was the D word, so I was gonna call it diameter.
Diameter is coming.
Reciprocal.
No.
Recipient?
Radical.
Radiator?
It's the radius. So you might want to jot that down somewhere. Sometime next time when we take a quiz in about a week, you're going to need to know that word. From the center to the circle, that's called the radius. Diameter is a word. To Does anybody know where the diameter would go if I draw you a diameter on here?
Like actual line of the circle.
No.
Oh, out of the circle?
This will be a C word. If we go the whole way around it,
Circumference.
that is called the circumference. C-I-R-C-U-M-F-E-R-E-N-C-E. If we go the whole way around the circle, that is called the circumference. It's just a circle fancy word for every other shape. What's it called when you go around it? What word is it?
No,
It's a P word.
the perimeter.
Perimeter. Perimeter goes around shapes. Circle's perimeter gets a special name. It gets called the circumference. I'm not sure why it gets its own one-of-a-kind special name, but the circumference is just the perimeter, the distance around the circle. Diameter, anybody have a thought on somewhere we could draw a diameter or something that maybe should have a name?
Inside,
It is inside the
like
circle.
inside the circle, not outside.
Yeah, if we do all of the inside, it's still going to be called the area, but the diameter is a certain thing I can draw that does stay entirely in the circle.
Like that.
Kind of like that. If we go the whole way through the circle, like the longest possible path through the circle, that is called the diameter.
How is that?
So the radius goes from the center to the circle itself. Diameter goes the whole way through the circle and has to touch its center on the way. So I think the homework will ask some questions like, if the diameter is 12, how much would the radius be?
Half.
So 6. Radius is always half. So if the radius is 5, the diameter would have to be 10, because the diameter is always double. Because really, it's made up of 2 of them. This right here is another example of a
Diameter.
Radius.
radius. This is a
Radius.
radius, because it goes from the center to the circle. If we stack them side by side, 2 of these, the plural of radius is radii, which is sort of a weird word. But if we go 2 radii side by side perfectly, that makes 1 diameter. The other C word that I didn't think people would know is called a chord. It has the silent H in there. It looks like chord. It's not. It's a chord. I'm not asking you to write that down or know that. That's not in the book, but someday in geometry you'll see it. If we go through the circle, but not the longest way possible, not going through the center, but we just take a path through the inside of the circle anywhere, that's a chord. If it happens to go through the center, so be it. But if I have myself a circle and I draw something like that, that's a chord. If I draw something like this, it's still a chord, but since I probably clipped the center, it's also called a diameter. The words you need to know though for about a week from now when we'll quiz, circumference goes around the circle, that's like the perimeter. Radius goes halfway through, touches the center. The diameter goes the whole way through, touches the center. And then something, you should know the word center because that's kind of like the whole,
There's
the
2 C's.
the main thing.
Oh wait, we already got
3
the
C's,
circumference.
yeah, center, circumference, and then chord, radius, diameter. Someday, not today, we'll talk about how you measure the circumference. If I give you the diameter or give you the radius, there is a way to figure out the circumference. Just as a curiosity, does anybody already know that?
No.
So we'll save that for another day. I'll tease the idea that it has to do with a very special one-of-a-kind number that's unlike most other numbers.
I would think you would take the diameter and times it by 2.
Yeah, that won't do it, but someday, we'll get you that someday. That's all we've got for the lesson, so with time we have left, about 20 minutes I think, we can kick up this homework. So we're going to go to 3 different pages. So the first place we're going to stop is 233, and we're not going to do much on 233. 233, there's an A to D, and there is a number 5 that has to do with volume. It's a volume question the way I first started to ask, like, how many blocks are on the top? How many levels like that are there? So how many blocks are there altogether? They're going to like take you one step at a time through a series of questions to do one volume, but it made 4 letters there on 233. 236, we're only going to do a little baby bit of that. There's 3 volume questions on 236. So we're gonna do just 4, 5, and 6 part of that homework, but there weren't even any letters on that. They just continued on that lesson to explain volume. This was lesson 98 when they were drawing pictures this way, and then it was like lesson 99 in the book that they just drew it more like a regular way. 236, no lie, 238 is where we'll set up shop mainly for the homework. We're just gonna do all of that. The 238, there's letters there that's just gonna like quiz you on the words again. They'll ask what's this called, what's that called, and you're gonna use the 4 words that you learned at some point in doing that. And then the 1 to 25 is just like a mix of everything you've ever seen. So that's our homework, mostly 238, just a little bit, 233, a little bit, 236. Can you hit the stop on that, please?
Oh, yeah, I forgot.
Thank you.